Greetings, everyone. This is Randall Carlson. I am a professional designer and builder, build projects for a living, and I do lots of solar design, passive solar design, rainwater harvesting, that kind of things. But my avocation, which is consistent with my academic training, is in geology and earth changes for going on a half century. One of the things that I've been very interested in, or I would say a number of the things that I've been very interested in, is mass extinction events in Earth history. I've also been interested in both endogenic and exogenic phenomena, and by that I mean endogenic being from within the Earth, which would primarily be volcanic activity or anything involving plate tectonics or seismic activity, and exogenic is from outside the Earth, which primarily would involve solar radiation, changes in the sun, coronal mass ejections, solar proton events, along with impact phenomena such as cometary and asteroidal impacts to Earth. So I've been looking at how these phenomena interact, what they have led to in terms of changes within the biosphere, and then ultimately how they have affected the rise and fall of human civilizations, which is kind of where my focus is at now. How civilizations have arisen in the past, been affected by natural environmental changes, and how those civilizations may have declined catastrophically. And it's a firm conviction of mine that if we're going to have any kind of an understanding of the future, our future on this planet, and how to create a sustainable civilization, we have to understand the past. We have to understand the factors that have been playing out over the centuries and over the millennia and longer. And if we are not cognizant of those processes, we might find ourselves in a lot of trouble at some point in the future, because there are natural cycles of oscillating glacial, interglacial ages. We still don't understand all of the forces driving these changes that force the planet into a full glacial mode and then force the planet out of a full glacial mode. And just when we think we're about to understand these processes, we discover that it's more complex than had been previously assumed. We know that the Younger Dryas literally happened in a matter of days. And so there's now a great deal of proxy evidence that is accumulated that would suggest that there was some kind of an impact event involved at about that time. What the exact nature of that event is still controversial, but it does certainly seem to be shaping up that there was some type of a cosmic event that involved at least one impact. I'm more inclined to believe it was multiple impacts, possibly even not all one event, but maybe several events over a matter of months or years. And there's evidence that perhaps there was a very large comet that disintegrated in the inner solar system, say between 15 and 20,000 years ago, and littered the inner solar system with a tremendous amount of cosmic debris, which the Earth could have encountered on multiple occasions with varying levels of consequences. There's also evidence that the sun was playing a role, coronal mass ejection, solar proton events, so on. And this is one of the things that I've really been focused on for the last about 22 to 25 years, and have spent most of my time in the field examining the geomorphic evidence for extreme climate and environmental changes. So one of the things that would lead to, for example, is the sudden demise of the great ice sheets at the end of the late Wisconsin Ice Age in North America, which coincides with the whole Younger Dryas phenomena, and the melting of the ice that occurred during the deglaciation, which was on a scale that at this point is utterly inexplicable. The meltwater floods that issued off of the ice sheets, say between 11,500 and about 14,600 over a period of about 3,000 years, were phenomenal, almost beyond imagination. And what I've been led to as my dominant theory as to what triggered the floods would be a series of impacts into the ice sheets. And I first publicly proposed this idea in the early 90s. I gave a series of lectures at Warren Wilson College in North Carolina in 1995, where I in detail, I broke this whole scenario down and suggested that there were multiple impacts into the ice sheet that triggered climatic changes that led to the end of the glacial period and caused massive flooding. So it was very gratifying to me that in 2007, a team of scientists came out with the evidence that, yes, it looks like there is the signature of some kind of a cosmic impact event right at the Younger Dryas boundary, which at the time was generally estimated to be about 12,900 years ago. The impactors are a part of the cycle, and how that would be is an interesting question, because the impactors are probably going to be, well, they are going to be either comets, the byproduct of cometary disintegration, or asteroids. And what we now know is that there's no clear dividing line between comets and asteroids. There's almost a continuum between the two, where a cometary nucleus is one end of the continuum and a dead rocky asteroid is the other end of the continuum. And I think that we could definitely say that there's evidence for a cyclical character to these events, which could relate directly to something happening on a galactic level, such as the galactic core explosion, that could be causing cascading showers of comets to enter the inner solar system. That sounds plausible to me. I think that there is ultimately something occurring on a higher level, a galactic level probably, that modulates the flux of cometary objects from their reservoirs in deep space, predominantly the Kuiper disk, and to the inner solar system, where they can now basically come alive and become active and start influencing, shall we say, the cosmic weather of the inner solar system. The problem with an ice age is simply that you have to have a whole lot of glacial ice accumulating very fast. And the process there requires, obviously, that the climate has to be cold enough that the seasonal accumulation of snow doesn't melt, such as it does now. If we look in Canada now, yes, there are many feet of snow every year. Come spring, that snow melts away. We have to imagine a scenario, though, where it snows and spring doesn't come for maybe 10,000 years, and that snow just continues to accumulate and compress into glacial ice, right? Now, at the end of this process, we have to come up with a way of melting that ice very, very fast in a geological sense. In this case, we're talking about 3,000 to 5,000 years maximum, from late glacial maximum, full glacial mode, into the point where only residual ice remains and it's melting away, and the climate of the Earth has gone through from one phase state to another phase state, if you want to describe it that way. So when you have the onset of an ice age, of course, here's the conundrum. The conundrum is that you've got to have a very large, rapid accumulation of glacial ice, which requires that the climate be cold enough that that ice does not melt, disappear through seasonal melting. At the same time, you have to increase the amount of evaporation from the oceans in order to loft this much moisture into the air that can precipitate out as snow that ultimately is compressed into glacial ice. The problem is, as you can see, is that it requires heat to move that, to transport that water vapor out of the ocean. So on the one hand, it seems to the conveyor belt, the hydraulic conveyor belt that is moving this moisture from oceans, precipitating it out onto land, is essentially gone in, it's on steroids, if you will. It goes into hyperactivity in order to begin to build up the glacial ice as quickly as it accumulates. But at the same time, to get that moisture out of the oceans and into the atmosphere requires heat. So there's the kinds of conundrums that we're confronted with when looking at this. See, our predecessors from a few generations ago had it a lot easier because they could imagine that the whole process took 100,000 years or longer. We don't have that luxury anymore. We have to confront the fact that these processes that normally we assumed took tens or hundreds of thousands of years happened over a few millennia.
We come now to a necessary compilation of information and evidence, the charge of Cuvier and Hibbins, to explain the catastrophe and all the evidence, requires tying all of these pieces of the puzzle together. If there is a massive stream of comets that the Sun encounters cyclically, it could account for the entire process we're seeing in the system. This would have the deficiency of not currently being visible, however. When one considers the galactic core explosion, any cosmic rays from a galactic wave would arrive and begin the disaster long before the comets and material, especially if they started from relative rest in the Kuiper Belt or had to travel from the center of the galaxy, and that could be by possibly tens to hundreds of thousands of years. Tough to make a cycle out of that. We also don't see many core explosions like that in the galaxies of the cosmos. But what about this idea of the galactic current sheet? The one that seems to be confirmed by Chan Thomas's older concept of a magnetic null zone. In previous episodes, we covered how the galactic electric field is likely a rippling current sheet through which we could pass cyclically, much more often than the galactic equator, and which would in fact be the polarity reversal point and magnetic reversal zone at a galactic scale, and which could have drastic effects on the Sun. The sheet is a double layer, but can also be thought of as a thin, consistent region differentiated from the opposing polarity hemispheres above and below it. While we see these regions everywhere around stars, planets, and galaxies, it is where both the organized spherical material and the loose, free, rogue objects orbit the larger sphere. In gravity, plasma toroidal, and electromagnetic models, this material clings to that central field. So in addition to being an electromagnetic disaster, the galactic sheet is likely to be full of dust, asteroids, and would-be comets as they activate on approach to the Sun, or rather, as the Sun's solar wind and photoionizing radiation approaches them. This would leave impactors to be a likely, if not necessary, component of the galactic field crossing, and is possibly the only way to tie the Sun, galaxy, and impactors to a cyclical Earth catastrophe. Here's some more from Randall Carlson.
Actually, today is my birthday, and I'm turning 68 today, and I really began these studies literally about 50 years ago, once I got out of high school. And I was able to spend a great deal of time traveling, and I traveled around the western states quite a bit, Montana, Wyoming, Idaho, Washington, Colorado, Utah, and I became obsessively interested in geology. And about that time, my business really began to take off. So I discovered that if I could do a project and finish the project and turn a modest profit, it would allow me some free time that I could go travel and do research and exploration and that kind of thing. So that's kind of how I've set up my vocational and my avocational life. So that's kind of where my perspective is. Like I said, my primary interest now is in trying to understand how these natural climatic and environmental changes have affected the rise and fall of civilizations. Another corollary that is sort of emerging from these studies is the idea that civilization is far older, deeper, and more complex than we even imagined a generation or two ago. There's no reason now for a knee-jerk dismissal of the idea that there may have been something that could be legitimately called civilization, say 20,000 years ago. The problem is that the evidence for such a civilization only exists circumstantially. It is not so much the hard evidence that we would use when looking, for example, at ancient Egypt or Sumer or the megalithic culture of northwestern Europe, where we can actually see the handiwork and the artifacts. And then, of course, the written record. And all the artifacts in the written record essentially go back about 5,000, maybe 6,000 years maximum, and that is considered to be the duration of modern history. But what has not been factored into the equation is the enormity and severity and frequency of these global environmental changes and the profound effect that they have on the landscape of the planet in terms of erasing pre-existing landscapes and replacing them with essentially new landscape. And so I've been tracking these floods in northern United States and in Canada on multiple occasions with several of my good friends and colleagues, and we have been documenting this evidence that is etched into the landscape. And one of the things that has really begun to impress itself upon me by spending somewhere between 60 or 70,000 miles accumulated in field observations over the last 20 25 years roughly, is the scale of this phenomenon is so enormous that mainstream academia and mainstream scholarship has tended to miss the picture because it is such a vast scale. Now, what has occurred is that there's been a lot of local and regional studies going back 100 years and longer, looking at evidence that suggests that something very extreme, something very extraordinary happened at that particular location. What hasn't happened until only recently is the coordination and integration of these regional and local studies to see that what we're actually looking at is a much larger phenomena that left its imprint in many, many locations around the planet. So one of the things, again, like that I have been really exploring is the mega floods that were associated with the melting of the great ice sheets. And these floods, in some places, particularly out west where they are the most extreme, this would be in the areas of northwestern Montana, Idaho, eastern Washington, in the so-called Scabland complex. The Missoula Flood phenomena is often called, which is the conventional idea is that there was a great proglacial lake in western Montana that was held in by an ice dam. The ice dam broke and released a tremendous amount, about 650 cubic miles of water that raced over eastern Washington, scouring away huge amounts of loess topsoil and basalt bedrock, and leaving an anastomosing or branching channel of interconnected coulees and canyons and deeply scoured bedrock. There's a theory, which I just mentioned, the idea that there was a proglacial lake that was held in by an ice dam. I've been challenging that idea now for several decades because I don't believe that studies of glaciology support the model that is now being invoked to explain the origin of these floods, which is basically that you had this massive lake held in by this glacial lobe of the what is called the Cordilleran ice sheet, which was over the Canadian Rockies predominantly. The problem is that ice is a porous medium, and at the location where the lake water presumably met the glacial dam, the lake water was 2,100 feet deep. Now, this induces a basal pressure at the bottom of the water column in excess of 960 pounds per square inch. If we look at modern examples of proglacial lakes held in by ice dams, what we find out is they are typically fail when they are 3 orders of magnitude less than the scale of the putative ice dam in northern Idaho that held in Lake Missoula. What we see is that ice is a very permeable medium, and it is very unsuitable for retaining water to any significant pressures. Yet, the fact is that this process has been invoked over and over and over again. It is now suggested by some researchers that an ice dam formed and failed up to 90 times based upon studies of the sedimentary column that was left in the wake of these flooding events, which means then that you had to re-advance the ice. The ice had to reseal the particular valley, which in this case is the mouth of the Clark Fork River that flows out of Montana and spills into Lake Pend Oreille in northern Idaho. So this would have been the location of the presumed ice dam. But again, the problem is it would be virtually impossible to affect such a scenario even once, much less 40 or 50 or even 90 times. And I think there are alternate explanations for the origin of those floods. And I've spent a considerable amount of time in British Columbia tracking what I believe to be the ultimate source of the floods, which would actually be up near St. George in the Plateau region, the Chaco Plateau region of British Columbia. We have a very large cometary nucleus coming in to the inner solar system, such has been hypothesized by a group of British astronomers that are oftentimes referred to as the neo-catastrophists. You have a very large comet entering the inner solar system, and it begins to fragment. That fragmentation process could take millennia to complete. The end result of that whole process of cometary disintegration is essentially just cosmic dust. But there's everything in between a single integrated comet nucleus, a meteor stream somewhere in the middle, and then a stream of cosmic dust at the other end of the continuum. Now, if the Earth encounters any of that stuff, there will be consequences. For example, Earth sweeping through a stream of cosmic dust, that dust will accrete to the Earth, to the atmosphere, increase the opacity and reflectivity of the atmosphere, causing a global cooling. So some process similar to this may be involved with the onset of an ice age. The other thing that has interested me a great deal is the legacy of ancient traditions that we've inherited from our ancestors, our predecessors on the planet that actually witnessed and lived through some of these phenomenal events and encoded these experiences into the legends and mythology and folklore. And so I have mined the mythology and the folklore and the legends and so on as a source of tremendous riches for gaining additional insight into these events that oftentimes, yes, are cast with a supernatural character, but that would be a natural outcome of the kind of reaction that a person, say an unscientific person would have when experiencing the kind of events we're talking about here. For example, an impact event could cause tremendous atmospheric phenomena. We know that if the sun becomes very active, it triggers aurora phenomena. And having once lived in northern Minnesota, I had the opportunity on several occasions to see very magnificent aurora borealis. And in the case of an extreme solar event, we could have, there could be some very impressive atmospheric phenomena that people would witness. We know from some of the great meteor storms in history that people have been utterly dumbfounded by the experience and believing that it was a harbinger of the apocalypse or the end of the world. We find that there is a modern mythology that has grown out of the Tunguska explosive event in Siberia in June of 1908. It actually spawned a new religion amongst the people. So we have a modern example where we can see, we can read the accounts of the eyewitnesses to the Tunguska event of 1908. And what is striking is the parallelisms between many of the ancient accounts, the ancient myths and legends, that sometimes even uses the same words and the same type of descriptive processes. The heavens opened up, fire poured forth from a rent in the heavens. The heavens parted like a scroll. Many of these kinds of descriptions you can see and read associated with the Tunguska event, and we find, from biblical sources, from Native American sources. And so that is another area of interest to me, is what we can learn about these kinds of phenomena by turning to these traditions that we've inherited from older times.